Yes, so gentlemen, are you ready? Oh. There is some technical issue because I see the presentation here, but it's not there.
Perfect.
Okay.
I will give floor to Bernardo.
Okay, so please welcome Bernardo Sargento with the presentation development of QGIS plugin to create wildfire likelihood, suspectability, and hazard map.
Hi everyone, my name is Bernardo. I work for Municipia in Lisbon. This is my colleague Nelson Mileu. And today we want to talk about the plugin, the QGIS plugin we developed to create wildfire likelihood, susceptibility, and hazard maps. So, wildfire is one of the most devastating natural hazards in Portugal. Between 2001 and 2015, more than 2 million hectares burned, and over 450,000 burnt in 2003, and over 300,000 in 2005. Last year was one of the most catastrophic years, where 440,000 hectares of forest burned and more than 100 people lost their lives. There is an important instrument that aims to prevent and minimize the effects of wildfires in Portugal. It is the Municipality Forest Fire Protection Plan. That is a plan created by municipalities and updated by their. The hazard maps that result from our plugin is a component of this plan. We didn't develop the methodology. All requirements and steps are described in the Portuguese Forest Authority technical guide. So, the hazard is based on two other concepts: the probability, that takes into account the history of occurrence in each cell, the susceptibility, that express if the territory has more or less favorable conditions for occurrence of wildfires, and the hazard result of combining these two concepts. Why build a plugin? Because our clients are municipalities, and it's their responsibility update the hazard map, because our clients use QGIS, because there is only available a very complex script to automate this procedure, and because our client asks us for help and for build this QGIS plugin. This is the graphical interface of our plugin. It's very simple. The required data to run the plugin is only the limit of study area, the plugins of burnt areas by year, the land use, like Corrinland cover, and the digital elevation model. All these data are available in internet for free. The The plugin, about probability, what the plugin does is a union of all polygons of burnt areas with a union Sargento tool, then creates a Boolean matrix with all the years of the series, where 1 corresponds to the areas that burn and 0 correspond to areas that never burn. Then, with the field calculator, creates a new field, applies the probability equation, sums every year, divides by number of years of the series, and multiply it for 100. In the end, converts the vector data to raster with the V2 raster attribute grass tool. So this is our probability map that shows us the average annual probability of each pixel to burn. About susceptibility, the plugin generates a slope map from digital elevation model and reclassify it with the reclass grass tool with the classes established in the technical guide. As the land use cover with it also reclassified with our reclass grass tool with the class established in the technical guide. The result is the map that shows us the reclassified susceptibility. Based on probability and susceptibility, our raster, our final hazard map was calculated, and finally we validate the hazard map using burnt areas, and we obtain success rate of 89%, which is very good, a very good result. Our conclusion: the tool is an automation process. It's a very easy to use and fast procedure. The next step is developed of the risk analysis component. Also validate model. Also a validation model will be included, and the plugin is available on GitHub. We are expecting getting it placed in QGIS repository. Thank you.
Okay, thank you, Bernardo, for your interesting presentation, and it's time for questions. Yeah.
Hiya. I wasn't 100% clear on the method, but so if a fire hasn't occurred in a pixel in the last 100 years, does it come out as being no risk in the final hazard map, or is there some kind of generalization in there?
No, so if there is no burned polygon, the principle is for probability. We have a series. All years, the institute delivers all the burnt areas in Portugal with in polygons. We use that vector layers to calculate the probability. If we don't have this data, we can use it for calculating the probability.
Sure. Okay.
That's the point. And also to validate. No, to validate, if to validate, it's another point. We can have other burnt areas, for example, from another source to validate the model, the final result. It's possible. It's also even possible to don't use a few years from the series or to validate the model. It's possible to, for example, 20% of the burned areas we left out, and then we use it to validate the model. It's possible. It's also possible. This is about the methodology that you were asking. It's a knowledge-based approach. Okay, it's not a probabilistic approach because it's it's an indication from the forest authority. You use that knowledge-based approach. We don't even discuss if it's good, it's bad. We think the results from the success rate are good, but it's a knowledge-based approach.
Sure.
Okay, thank you. And another question?
So, as far as I understood, you only take into account if the area was burned in the previous year, and if it wasn't burned, it will be burned in the future. It's quite this approach you are using. You don't take into account other like the meteorology.
No.
If there is forest management, these kind of things, you don't take this into account.
Yeah.
It's just you know that will burn in the future if it wasn't burned in the past.
This kind of models are what we call physical approaches. They are not dynamic models. They are static models. And what we are trying to reach is an hazard map. And we are not trying to predict a dynamic model with the wind speed, with the humidity. It's not what we want, definitely. What we want with an hazard map and a static approach, not a dynamic model. That's the approach that we want, and that's how we did it, and how the forest authority wants the final hazard map.
Okay.
Okay, thank you. Is there another question? Yeah.
It's based on Korean land cover, and it means also that if some area in the past had one code, now it's burned. It depends also on the methodology how it's reclassified. So if something was burned before, it will definitely difficultly burn now because it's just a bunch of carbon. And how does it take? I'm not sure. Is the model that is really based on Korean land cover, actually?
Okay, that's a good question. The land use that we use to test the plugin is the Korean land cover, but in practical terms, the forest departments from the municipalities use land use layers with more detailed and in another scale. About the question of the land use classes, of course, with more detailed layer, the type of forest, the different types are discriminated, even if the model is a knowledge-based approach. With a statistic approach, it's possible with bivariate models. We can discriminate the different land use classes with more detail, but we are just reusing their methodology, okay? But we use Korean land cover just to test the plugin. It's possible to use other land use layers. Of course, you need to make another recode files because we are using, if you saw, we use some recode with the land use codes. If you use another layer, you need to recode this layer. You need to adapt the plugin file, that recode files.
Thanks.
Okay, thank you. And are we having another? No. Okay, so thank you again, gentlemen. Thank you, Nelson. Thank you, Bernardo. And thank you all for attending this session regarding plugins. And I wish you a nice rest of the conference.